The moon is Earth's only natural satellite, and its importance to our survival cannot be overstated. Scientists believe it formed approximately 4.5 billion years ago through a collision between the early Earth and a Mars-sized object called Theia. The debris from this massive impact coalesced, forming the moon. Over time, the moon moved away from Earth to its current orbit, a distance crucial to the balance of our planet's systems. The moon orbits Earth in about 27.3 days and rotates on its axis at the same rate. This synchronous rotation is why we always see the same side of the moon. The gravitational relationship between the Earth and the moon is what causes this tidal locking. This gravitational pull is also responsible for generating Earth's tides. Tides influence ocean currents, which help regulate the planet's climate and sustain marine ecosystems. Without the moon, these systems would be disrupted, affecting weather patterns, temperatures, and biodiversity. The moon's gravitational forces also slow Earth's rotation through a process called tidal braking. This gradually increases the length of a day, which has been crucial in shaping the evolution of life on Earth. If the moon did not exist, Earth's rotation would be faster, leading to shorter days and potentially more extreme weather systems. As the moon orbits Earth, sunlight illuminates different portions of its surface, creating the lunar phases. These phases, from new moon to full moon, complete a cycle in 29.5 days, known as a synodic month. Throughout history, humans have relied on these predictable cycles for tracking time, developing calendars, and organizing agricultural practices. The moon's phases have been intertwined with human survival for thousands of years. The moon's surface reveals its geological history. Its outer layer, called regolith, is a fragmented mix of rock and dust created by billions of years of impacts. The moon's surface also includes vast plains called maria, formed by ancient volcanic activity, and heavily cratered highlands. These features offer clues about the moon's formation and the history of the solar system, providing a unique record of impacts and processes that have shaped celestial bodies. This knowledge is vital for understanding Earth's own history. Unlike Earth, the moon has no significant atmosphere. Without atmospheric protection, its surface experiences extreme temperature fluctuations, ranging from 127 degrees Celsius during the day to minus 173 degrees Celsius at night. It is also exposed to cosmic radiation and micrometeorite impacts. Despite these harsh conditions, the moon's lack of an atmosphere makes it an ideal site for scientific observation and exploration. The moon stabilizes Earth's axial tilt, which is critical for maintaining a relatively stable climate. Without this stabilization, Earth's tilt could vary widely, leading to extreme climate shifts that would make the planet less hospitable for life. The moon's gravitational pull ensures that Earth's seasons remain consistent, creating an environment in which ecosystems can thrive. The moon has been central to human culture and exploration. Ancient civilizations used the moon to measure time and guide their agricultural and spiritual practices. The first human-made object to reach the moon was the Soviet spacecraft Lunar 2 in 1959. A decade later, the United States achieved the first crewed lunar landing with Apollo 11 in 1969. During this mission, astronauts collected samples, conducted experiments, and left instruments on the lunar surface. These achievements marked a turning point in space exploration, demonstrating that humanity could explore beyond Earth. The moon remains a key focus of space exploration. Water ice discovered in permanently shadowed craters near its poles has opened up possibilities for sustaining future lunar missions. This ice can be converted into drinking water, oxygen, and rocket fuel. Additionally, the moon's surface contains valuable materials such as silicon, aluminum, and titanium. Utilizing these resources could support long-term human presence on the moon and serve as a foundation for missions to Mars and beyond. Studying the moon has enhanced our understanding of planetary science. Analysis of lunar samples collected during the Apollo missions has revealed the moon's composition and age, offering insights into the early Earth and the formation of the solar system. Research into the moon's interior, including its crust, mantle, and core, has provided evidence of its thermal and geological history. This knowledge is critical for understanding planetary processes and the potential for life elsewhere in the universe. The moon's location makes it an ideal platform for scientific observation. Its lack of an atmosphere allows for unobstructed views of the cosmos, which could support advanced astronomical studies. The far side of the moon, shielded from Earth's radio interference, is particularly suitable for radio astronomy. Observatories placed on the moon could revolutionize our understanding of the universe. The gravitational relationship between Earth and the moon continues to evolve. The moon is moving away from Earth at a rate of 3.8 centimeters per year, gradually affecting Earth's rotation and the dynamics of the Earth-Moon system. Understanding this relationship helps scientists predict the long-term evolution of our planet and its interactions with the moon. The moon's role in space exploration is pivotal. It serves as a stepping stone for missions to Mars and other destinations. Technologies developed for lunar exploration can be adapted for interplanetary missions. The moon's resources, such as water, ice, and minerals, could support the development of infrastructure needed for deep space exploration, reducing reliance on Earth-based supplies. The moon's significance extends beyond science and technology. Its influence on human culture, from ancient mythology to modern exploration, highlights its enduring role in our history. The moon cycles have shaped traditions and practices across civilizations, underscoring its importance to humanity. Recent years have seen renewed interest in the moon from both governmental space agencies and private companies. NASA's Artemis program aims to return humans to the moon, with the goal of establishing a sustainable presence. International collaborations and commercial investments are accelerating the pace of lunar exploration, reflecting the growing recognition of the moon's value as a scientific, economic, and strategic asset. The moon's impact on Earth is profound and multifaceted. It stabilizes our planet, influences its tides, and provides a wealth of scientific opportunities. Its resources offer potential for future exploration and survival beyond Earth.